Way back at the beginning of the school year, we talked about key concepts in geography. We talked about the study of places and spaces and the relationships between people and their environments. And you learned that there's two main branches of geography. Physical geography that talks about the landforms, the climate, and the ecosystems. And we talked about human geography, what we studied here this year. We talked about culture and settlements and the human impact on the planet. We talked through the key themes of geography. We talked about location, where something is, absolute location, and relative location. We talked about place, about the physical, the human characteristics that make somewhere unique. We talked about the human environment interaction. We talked about movement through migration, through trade, through the spread and diffusion of ideas. We talked about regionalization, where areas are grouped together by common features. Our first idea about location is absolute location. Where is something and what is its position on the planet? Oftentimes, I think about this with latitude and longitude. So we can use this to position something on a globe or on a map. We could also use GPS coordinates to show exactly where something is. Other times, we're talking more about where something is in relationship to other places. So we're talking about relative location. As you can see in the picture above, there's a signpost that's showing you if you were here, where would you need to go in order to find all the other places in the world? Rome, Toronto, Barcelona. Where would you need to go to get there? And where is this place in relationship to other places? When we're thinking about trade, relative location becomes very important. Are you near a body of water? Are you near an ocean? How close are you to the next biggest city? Sometimes we think about relative location as being how is a place situated or what is its situation. I live in Iowa, and we are situated between the Mississippi River and the Missouri River. I am east of the Missouri River, and I am west of the Mississippi River. And my city, Des Moines, is along some nice train tracks that help us to be connected to other places in the world. So when I describe Des Moines, where it is in relationship to other places or where it's situated compared to other places, I am talking about relative location. We also talked about place. So, what are the physical and the human characteristics that make a place unique? When we talked about the cultural landscape, how have humans impacted the planet? What have we put there? We're all thinking about when we talk about place, what is unique about this one spot on the earth and how is it different from any other place on the earth? If you've looked at the picture here on the right, you probably have identified that this is Paris, France. It's one of the most iconic and identifiable cities in the world, and that's because of the Eiffel Tower. It adds a sense of uniqueness to the cultural landscape that lets us know that this is Paris. In the past, we had lots and lots of unique landscapes. If you're looking here, maybe you don't know exactly where these two places are, but you probably identified that one of them is in Europe and the other one is somewhere in Asia. And places were unique because culture and humans' ability to make things was really dependent on the environment. And different environments around the world caused cultures to become different. We had different building materials available in one place versus the other. We were dependent on the environment for our architecture, for our clothing, for our food, and places were really different. They were all unique. But as we began to talk about today's cultural environment, we started to learn about the fact that not everywhere is as unique as it used to be. In fact, the opposite of place is starting to occur, and we call that placelessness, when there's a loss of uniqueness around the world. If I were to show you this picture of an apartment building, and I were to tell you that it was the United States, or it was in Egypt, or it was in Vietnam, it would really be hard to tell whether or not that was true or not, because buildings like this apartment building occur pretty much in many different places around the world. It's not unique to have a boxy apartment building that looks like this, made out of concrete. We have become a little bit placeless. When we look at the skylines of our largest cities, we see placelessness as well. Take a second, where do you think this is? It's hard to tell, right? Because the same multinational architectural Firms are making buildings all over the world. This one happens to be out of Mumbai, but it would be hard to say exactly where this city was in the world. We also talked about diffusion of humans and their culture. There's two main types of diffusion: relocation and expansion. Relocation is just about the movement of things or people. An expansion type is about those ideas or culture actually expanding out to new people. We have contagious diffusion, hierarchical diffusion, and stimulus diffusion. Relocation diffusion. When we're talking about relocation diffusion, most of the time we're talking about migration of people. And people, when they move, are going to move not only themselves, but they are also going to move with them their architecture, their language, and they're also going to move their types of architecture and their religions. Remember when we talked about colonization and when the British came to the Americas and they relocated to the East Coast, and they brought with them their language, and they brought with them their religion, and they brought with them their styles of architecture. And today, the East Coast of the United States looks an awful lot like the places that the early colonists relocated from because they brought with them all of their ideas. We also have the expansion types of diffusion: contagious, hierarchical, and stimulus. When you hear the word contagious, you probably are thinking about illness, right? A contagious disease that we might get. And that's really a pretty good way of thinking about what contagious diffusion is. Contagious diffusion is going to move fast. It's going to move person to person, and it's going to spread pretty quickly. Probably the type of contagious diffusion that you're most familiar with is going to be social media. When we put something out on the internet, it goes to our friends. And then if they like it and they share it, it goes to their friends. And it can spread pretty quickly once we put something onto the internet. That idea about contagious being like an illness has showed up in our social media too. What do we say when something really takes off on the internet? We say it went viral, going back to that idea of it being like an illness. We also have hierarchical diffusion. And unlike contagious diffusion that kind of goes to everybody all at once, hierarchical diffusion is first going to go to important people or important places. When I was in college, I worked at McDonald's, and there was the store manager who was in charge of the store. And then she had two managers underneath her. She had the store first and the store second. They were second in command. And when there was a decision made, store manager would tell first and second. Then we had shift managers. And after the first and the second manager found out about what was happening, the shift managers would know what was going on. I was Morningside. And then we would let the other shift managers know what was going on. And then we'd finally pass on the ideas of what was happening to the people who were the general employees at the bottom. We had a hierarchy of how we learned about what was happening: store manager, first, second, shift managers. And finally, the employees at the bottom knew what was going on. That's what a hierarchy looks like in hierarchical diffusion. Most important people learn about things first. Now, I just told you that social media was an example of contagious diffusion. And when you and I put something on the internet, it is going to be an example of contagious diffusion. But that doesn't mean that everybody on the internet is equal. We have social media influencers, we have pop stars, we have sports stars. And when they put something on the internet, it's going to spread differently than when you and I put something on the internet. When Taylor Swift says something, she's super important to a lot of people. And her followers are going to pay much more attention to it, and they're going to spread it to their followers because she has a lot more power than maybe what I do or what you do out on the internet. So, although social media in general is contagious diffusion, keep in mind that there are some instances in which it might be hierarchical. We also have hierarchy of place. If you wanted to become a musician and you wanted to make it big, you are probably not going to think, "Ooh, I want to be a musician. I'm going to go to Iowa." No, there's places that are more important to the music industry in the United States than what Iowa is. You might go to New York, you might go to LA, you might go to Atlanta, you might go to Nashville. All of these places are kind of hubs for the music industry. They're super important. They put out lots of music. And when there's a new music trend, you can guess it's probably going to be coming out of one of these places. And then it slowly trickles down to the rest of us throughout the nation. We're going to see that fashion is the same way. If you think fashion, places that are going to get the new trends first: New York, LA, London, Paris, Tokyo, Johannesburg, all these places way more influential in what's happening in fashion than Des Moines, Iowa. Last, we have stimulus diffusion, where the underlying idea moves, but it changes as it goes. For example, McDonald's. When we think of McDonald's, you think fast food, you think a hamburger, a beef burger. But as we look at the way that McDonald's spreads around the planet, it's going to move and it's going to keep a lot of those same ideas there, but it's also going to change. If you go to India, you're not going to get a beef burger at the McDonald's because beef is sacred. And we're going to see things like a lot of chicken. We're also going to see a lot of vegetarian options in India. So we see the idea of McDonald's move, but it's also going to change as it goes. If you're old like me, you know that the idea of a story in social media started off in Snapchat. In Snapchat, you could make a story. But today we have stories in Facebook, we have stories in Instagram. Pretty much every social media has this idea of a story. So the idea of a story spread. All these other types of social media didn't become Snapchat, but it did spread the underlying idea of a story. So there was a change that happened as it moved to different platforms. This would also be an example of stimulus diffusion. Now, in geography, we have quite a few tools. Our main tool is going to be a map. We also use scale and we talk about projections. We have different types of maps. We have political maps that show us where countries and states are. We have physical maps that show us things like where are our rivers, where are our oceans, where are our deserts. We have thematic maps that put data on top of maps. And we have topographic maps that show us things like mountains. When we're thinking about scale, the first way that we think about scale, and I'm going to warn you, geographers think about scale in a lot of different ways. So the first one is thinking about where is the distance in the real world versus the map distance. And usually somewhere near the key, you're going to see a map scale. And you could pull out a ruler and you could measure and you could do some multiplication and figure out exactly how far apart things were in the real world. A second way that geographers talk about scale is that sometimes we talk about large scale maps and sometimes we talk about small scale maps. What you need to remember is that there is an inverse relationship to the size of what is being mapped to its map scale. So here we have a map of the entire world. The world is a really big place. So this is going to be a small scale map. On the other hand, small places are going to have a big scale map. So we have a map here of the transit subway system for New York City. Relative to the entire world, New York City is pretty small. So we would say that this small local map has a big scale. Remember, it is an inverse relationship. Sometimes we also talk about map scale and scale of analysis. And one of the things that College Board really likes to talk about is the way that changing your scale can change the focus of the way that we see the world. If we look at the map on the left, this is a map of the United States. So the map itself is a national scale map. But the scale of analysis is how are we getting the data? And if we see and look over at the key, we see it's county percent. So they're presenting the data or the scale of analysis by county. On the right, we see a map of the whole world. So we have a global map. But the scale of analysis, how we're getting our data about what's happening, is going to be by country. We can see that when we're looking at the country scale, you'd see the whole United States as being one color. But it's very unlikely that really every place in the United States would actually be the same. So when we would switch scale to something like a county scale, we would see a lot of the different variation and more specifically where we would find things in the United States. Keep in mind, College Board really likes us to think about how do we see different details at different scales. So we have a lot of different types of thematic maps. Remember, this is where we're going to put data on top of what we're learning about. We have dot maps, ice-line maps, cartograms, graduated symbol, and choropleth. Here we have the dot map. I think this is the easiest one to identify because literally there's dots on it. I want to point out one thing, though, about dot maps. Dot maps are really good about showing us where things actually are occurring. The map on the left is going to be a one-to-one dot map. So it's about homicides in the DC area. And each one of those dots is going to show us exactly where a homicide occurred. So we can see patterns of where things actually occurred. The map on the right, on the other hand, is going to be about acres of harvested wheat. This one is not going to be an exact position dot map. It's still going to show us concentration, but you need to look at the key. So we can see that one dot means 10 acres per square mile, but it's kind of an average. Then we can see that as the concentration increases, we would have, for example, the most densely clustered would be 130 acres per mile. This is going to kind of generalize where things are occurred. So we can be a one-to-one dot map, or we can be a generalization dot map. And the only reason you're going to know the difference is if you actually read the key, reading the title of the map, reading the key, reading any other information that College Board puts around a map or a piece of data is going to be really important for you to be able to understand what's going on. We also have ice line maps. These are going to use lines to show us generalized areas in which they have the similar data. For example, over here, this area right in here is going to, we have 11,000 feet to 11,500 square feet. So everything within this area is going to be within that height. We also see ice line maps oftentimes when we're talking about climate and weather. One of my favorite types of maps is a cartogram. I think cartogram sounds kind of like a cartoon, and I think these maps totally look cartoony. So here we've got a world map of organic agriculture in hectare. Remember, hectare is about the size of a football field. And we can very easily see what regions of the world are using a lot of organic agriculture. Keep in mind, organic is a very specific designation. Oftentimes it has to be certified. And you can see, if I were to say what areas are using a lot of organic agriculture, you can see right away by this map that we see a whole lot of agriculture that's organic in Australia. The places are going to get bigger if they have more of something, and places get smaller if they have less of something. Graduated symbol maps or proportional symbol maps are going to have the symbols get bigger and smaller if there's more of something. So very small dots in this case mean there's not very much of something, and big dots mean there's a whole lot. We can also have choropleths. They're going to use color or patterns in order to be able to show us concentrations of things on the map. These are usually pretty easy to read. Here, the darkest greens or blacks are going to show more wealth, whereas the brownish color at the bottom is going to show much less wealth. We've also talked about density. We have three types of density that we have talked about. We have population and arithmetic density, which is the total population divided by the total land area. We have physiological density, that's about the total population to the total arable land. Now remember, arable land is going to be the land that we can farm. So it's going to tell us in physiological density how many people do we have to be able to feed for each acre or other unit that we have of land available to grow food. This tells us a lot about the carrying capacity of a country. If we look at the population of Egypt compared to the total land area, it looks pretty good. But when you realize that really the only place that they have with arable land is right around the Nile, it suddenly makes it have a whole really high physiological density. We also have agricultural density. This is farmers for arable land. This is going to be a pretty good way for us to be able to tell how developed a place is. Here in the United States, we use a lot of technology and a lot of machinery in order to be able to do our farming. So one farmer can do many, many thousands of acres of land, whereas people in less developed countries where they're using subsistence agriculture, it's very intensive. They're using lots of human and animal labor. They can't use as much land because they simply can't by themselves produce as much labor as what a machine can. So if you have a lot of farmers, because you're using subsistence farming, your agricultural density numbers can be pretty high. Whereas if you're using modern agriculture and you're relying on a lot of machines, you're instead going to have a really low agricultural density. So I wanted to take a second and think again about that idea of scale. So here we have a map, and it's showing us very specifically on a global scale, where do we have our clusters of population? And we can see that there's a whole lot of people in India. We can see that there's going to be a lot of people in China. We can see that around all of the coasts, we have clusters of where people live. We can see the clusters of the cities. We get a pretty good idea about where people actually live. Now I'm going to switch scale. So our map at the bottom, our scale of analysis is now by country. Suddenly, the United States, our population density all becomes one. We can't see those details of where people actually are. So it's communicating the same information, but it's communicating it at a different scale. And suddenly, we don't know exactly where things are occurring anymore. When we're thinking about analyzing geographic data, we also oftentimes think about concentration and patterns. So, where are things and how are they placed? And when we're talking about where things are and how they're placed, there's some vocabulary words that we should know. We often talk about where things are clustered or where are they dispersed. So where are they together or where are they spread out? And is there a regularly occurring pattern that we can kind of use to predict about where things will go? Let's take a look at how this might look in the real world. Here we have some rural communities. On the left, we have a clustered agricultural community, and on the right, we have dispersed. The houses are far apart. Oftentimes in our cities, we also have very regular patterns. We're going to have our houses lined up nicely on streets. They're going to have a driveway that connects. There's going to be a backyard behind the house. We have regularly repeating patterns that we could use to predict to see where things are going to go. Another tool that we use in geography is going to be GIS, or a tool that we use in order to layer data together. So when you are looking at your what we call a GPS in our car, it's really a layer of a lot of different data. So you're going to have maybe a satellite layer, you might have a street layer, you might have names of the road layers, you might have where schools and buildings are, and all of this data layers on top, and then your position is kind of placed on top of this. Well, that system that layers all this different information together is our GIS, or geospatial information system. Sometimes we use remote sensing. which is satellite, aircraft data, or LiDAR. So we can see on the left, we can see a satellite image of a city. Our satellite images have given us very specific data about what do mountain ranges look like, what do cities look like, and they're getting better and better so that they're able to very specifically see things. We also can use things like lasers and LiDAR in order to kind of do an analysis of what things look like. Here in Iowa, we have the effigy mounds, and we use LiDAR to analyze it and see a little bit better what some of those images look like. We also are going to use GPS, and we have a series of satellites that are going to be circling the Earth. It used to be 24 NavStar stars, but we've added in a lot of military satellites that have made it even more specific. And there's kind of three parts to a GPS system. You have the satellites, you have a um, something that will be trying to be in contact with those and figure out where you are in relationship to those. And we have tracking stations that are going to make sure that all of our satellites are in the right position. This tells you where exactly you are on Earth. To get a very exact position on Earth, you need about 4 satellites. You can get imprecise with 3. We also have different regions in the world. We have formal regions, functional regions, and vernacular regions. Formal regions have defined borders, and they also have verifiable data behind them. For example, we have Belgium here. Belgium has a lot of semi-autonomous regions within it, and that's partially because they have different languages that are spoke there. So language religions, religious regions, and countries are all going to be examples of formal regions. These have defined borders and data to back them up. Functional regions, there is a central node with influence for a specific area. Think about distance decay. The closer you are to something, the more you interact with it. If you live in Minneapolis, you are very likely to be a Twins fan because you're the closest to the Major League Baseball team of the Twins. If, on the other hand, you live in Seattle, you're much more likely to cheer for the Mariners. The closer you are to a professional baseball team, the more likely you are to cheer for them. Farther away, way less likely. Vernacular perceptual regions are based on some sort of cultural perception of a place. For example, we're in the Midwest, or we could talk about the South in the United States. It's really kind of hard to say exactly where the South begins or where the Midwest begins or where those stop because it's really based on different people's cultural perception of the world. We also have a problem with maps. Our planet is round. The world on maps is flat. And it's really hard in order to go about making a round world flat. We have distortions that occur anytime you're trying to make something round flat. You're either going to have shape, size, distance, or direction distortion. And there's 3 main maps that we probably need to know. The Mercator projection was invented in order to help sailors know which direction they needed to go. It keeps direction accurate. But when you do that, you end up distorting everything else. And if we look at this map, right up here, Greenland looks giant. It looks the same size as Africa. In reality, it's significantly smaller. The Mercator projection is most accurate with size at the equator, but at the edges gets extremely distorted. We have an equal area map that tries to make all of the sizes of the different land masses about equal, but we end up with vastly distorted shapes. And then there's the Robinson projection that tries to be kind of a middle ground between those two. There's thousands of projections. Probably the 2 you should know the most are Mercator and the Robinson. You should probably also know about space-time compression. And this is the idea that our technology has improved so much that we can get almost anywhere in the world very quickly. Back when you had to take a wagon across the United States, it took months. Today, you could take the train across the United States in a matter of days. We can call anyone instantly. The world feels smaller even though it's the same size because we have increased our technology. And lastly, take a moment, write down what is environmental determinism, possibilism, and what is sustainability. Can humans adapt, or is our culture determined